Today we are walking through Self-Distilled Agent, IC Reinforcement Learning. A paper about making reinforcement learning for LLM agents more stable when the agent has to act over many turns.
So the target is not a one-shot answer.
Exactly. Standard RL can tell the agent whether the whole trajectory worked, but it does not clearly say which token or action inside a long interaction deserved credit. OPST tries to add token-level teacher guidance, but this paper shows that using it naively can become unstable.
What makes the teacher guidance risky in this setting?
There are two linked problems. First, in a multi-turn environment, once the student drifts away from the teacher-supported path, later token guidance can point at the wrong context. Second, the teacher gets privileged skills during training, and the teacher rejection can be caused by a weak retrieved skill rather than by a genuinely bad student move.
Then what does SDR change?
This diagram is the core method. SDAR keeps GRPO, the verifier-driven RL objective, as the main optimization backbone. The OPSD branch uses skills and the self-teacher, but its token-level losses pass through a gate before it is added to the training objective.
What does that gate decide at the token level?
It asks whether the teacher is giving a useful endorsement for the exact token the student sampled. Positive teacher-student gaps strengthen the auxiliary distillation signal. Negative gaps are softened instead of being trusted blindly, so the RL reward signal remains the anchor.
Can you define the gap without diving too deep into notation?
The gap compares how much probability the teacher and the student assign to the same sampled token. SDAR wraps that gap in a sigmoid. That is why the auxiliary loss can guide useful tokens without exploding when the teacher and student disagree strongly.
Does the paper show the instability that this is trying to avoid?
Yes, on the left, multi-turn OPSD keeps a noisy success rate while the KL divergence rises across turns, which means the student is moving farther from the teacher-supported behavior. On the right, our LSD produces a large early KL spike, showing that rewriting our L updates by self-divergence can over-amplify mismatch.
So the key is not just adding a teacher, but deciding when the teacher is trustworthy.
Right. The gap analysis shows many tokens have negative teacher-student gaps. The middle and right panels also show that the gap varies across turns and positions. That supports the paper's claim that a uniform distillation weight is too blunt for multi-turn agents.
How does that behavior evolve during actual training?
The training dynamics are important. The average teacher-student gap starts negative but moves closer to zero, while the gate activation ratio gradually rises. In plain terms, SDAR begins cautiously, suppressing many questionable teacher signals, then lets more tokens receive distillation as the student becomes better aligned.
What is the main result when they compare against the baselines?
The result plot says SDAR is not just more stable, it is stronger. On the 7 billion setting highlighted in the summary, it improves over GRPO by 9.4% on ALF World, 7.0% on Search QA, and 10.2% on Webshop accuracy. It also avoids the collapse seen with naive GRPO plus OPSD.
Does it still work when the retrieved skills are imperfect?
That is one of the more practical findings. With random retrieval, the method still beats the pure GRPO baseline by smaller margins. With keyword matching, it gains 4.7 on ALF World, 8.5 on Webshop score, and 10.2 on Webshop accuracy. So the method is not simply relying on perfect skills.
Did they compare different gate signals too?
Yes, the ablation compares entropy, a software score, and the teacher-student gap. The gap-based gate climbs to the highest success rate, roughly 0.84, and rises faster after the first 100 training steps. The paper argues this because the gap directly measures teacher disagreement on the student's chosen token.
Then the final takeaway is that the teacher is useful, but only through a controlled side channel.
Exactly. The paper's central claim is that multi-turn agents should not copy privileged teacher signals uniformly. SDAR keeps reward-based RL in charge, then selectively distills the teacher only where the token-level evidence looks beneficial. That is how it improves stability and performance across ALF World, Search QA, and Webshop.
Got it. The lesson is to use the teacher as a careful advisor, not as the driver.
That wraps up this paper walkthrough.